Hello, my name is Michael Wickerson, and I am the Senior Researcher at Fader AI, where we build design software in the AI era. Your first step will be to load the app Fader AI into one of your browsers, and you'll see a tutorial video on the trabeculae pop up in the middle of the screen. You can then click on any part of the other screen, and you'll see that there'll be an opportunity for you to sign in for free and prompt anything you like, let's say the word sphere, in the text prompt editor down at the bottom. And a pricing tab will come up which would show you the subscriptions and plans that exist for people interested in this software. I'm going to focus in on the user interface and about 6 use cases. The first of which is you'll notice that you have a mouse that can spin around, which acts somewhat like a gumball, but not quite. We're working on developing that into a tool that you can do some editing with, but you have to think of text to create is the basis of Fader AI. The whole point of this is that you can start talking computationally to your software and see things generate in 3 dimensions. There are some toggles, which I'll cover up near the top, of putting your edges on and off your form. You can toggle off the grid, which exists above and below the form. This happens to be a fairly large model. You can set it to metal, double-sided metal, plastic, glass, and wireframe. You'll notice that after I did my prompt, I have a params editor that can pop up or not. We are going to indicate the units on something like this, which to me, in my creation computational studies, matter a little less, but that's no reason why it's not there. Right now it sits at 10 units, and you can move that and direct fairly quickly, scaling things differently. You could have said, obviously in the toggle the param editor, you have the radius you can adjust, but the magic really does happen over here in this prompt. Up at the top, I'll go into details in a second, but you notice its main operation is describe the desired 3D objects, including specific dimensions, shapes, and colors, and any parametric features. Explain basic steps process with a parametric design logic. Why we say that is because you don't just tell it to make something and it reverse engineers it. If it does that, it will make very simple platonic solids and bring your forms together in its most logical but simple way. So this tool really does function as someone who does think from the ground up as they build their designs, at least for my practice. You'll also notice that there's a drop image for extra prompts context where you can drop in any image you would like that would inform your model. So already it's pretty magical. Up here, we've got a really nice toggle a button that you can click for saving files. You'll notice scrolling across there, you can delete files if you don't like them. You can copy files. Let's say I had the spheres file selected and it's turned green. I can copy that file and have another version of it. And what you would then want to do is probably delete that file. You can rename the project if you don't like the way it's named files because of the first letter in your first prompt, or if you just used a single word, it will take that. And you can download your project file as a Fader file, an FTR file. That is an iterative recording or memory of all the steps you've done in your text prompts. I've said a couple of things that are pretty magical in my mind already. That happens to be one of them. You can select a file if it's something you really like, and you can share that. It will copy this sphere. So if I hit this one, it will copy that. As we press on sphere, it is copied to my clipboard, which I can then send to anybody to open up in Fader. And you can add models over here. The next button is to erase your model if you didn't like that sphere. You can take a PNG of it. And this snaily little wonderful squiggle is the rendering of it using AI, which actually is influenced by, if I said Earth, I would get a little slower, but I would get a render of this sphere in a kind of 2D rendering of what it would be represented as Earth. And the last one is very important. You can export as a GLB, STL, step file, and fader file. That's there because we are in the process of pulling things into Grasshopper. So whenever I download a GLB of this, the GLB will go to my downloads, and now I'm ready in Grasshopper, which I'll show you later, to open it up. That's enough for the first step of this video. We will move on to phase 2. This is a nice example of the simplicity, but also how people might get started. And you'll also notice these little eyes on the side that I can back off to the initial prompt, which was coffee table. And coffee table came up looking fairly simple. Params were entered into the equation. I could do my editing on these params tabs, or I could start to do image prompts to inform it, or that computational text prompting. And I chose to do that in the way I enjoy, a mathematical way of using derivatives. So, second derivative, make a hole in the thin glass inlay. Pretty simple. It did exactly what I wanted. And as I ran through with my prompts, I slowly took it up to a model that I'm pretty happy with, and I could start to explore. I could look at it's just a filleted form, and I could take it now to clips that would hold up the glass table on the bottom. So an iterative understanding of what you're doing. Here's one that went a little farther. The first prompt was fairly simple and pretty crude, but there it is, sofa. It gave me something with the parts and parametrically controlled. I then ran through the entire process, and as I moved through it, I thought to myself, this is more like a fabrication of a cold-rolled steel finished form, possibly an outdoor park bench, and something that could be made by the processes of what I'm used to, metal casting and metal foundry, and certainly welding and fabrication. And in the end, I showed an example of asking it to put in a light red to orange gradient. So knowing my experience from other softwares where you're applying those as node scripts or applying those in coding, you can do that by just literally text prompting it. Here's an example of one of the most important buttons in Fader. Over here, down in this section, I can basically click, and I think I will do that back over here. I can click, not just select, send my text prompt of Sphere, not just retry it or undo it. We are in the process of taking people's GH3DM as GHX files, having them programmed and then hopefully parsed in full detail into macro files that our language will control in Fader and understand and see a familiarity in those things. I had a gherkin. That was it. It's been programmed. A gherkin pops into the model. This simple shape of an architecture parametrically. Immediately after that, I said, could you please let me control that outer curve that's being revolved, because I knew how it was being made, and give me access to the coefficients. And it did that. And in doing so, I start to see the math, but I also gain more and more control over it. At this point, I did something very visual. I asked it to simply do the clockwise and counterclockwise trusses. And I started to play with a panel discussion of how I would call out forms, perhaps randomly. And in the end, I wanted to watch this kind of magic step. I asked it to become more like a high wire tower. Didn't really know what I was talking about. So I showed it an image prompt. And that was the image prompt. Now, this is where some real magic happens again, I think, for the third time in this video. It was wise enough to look at that picture and decide, watch what happens when I click this button. Watch what happens to the coefficients. It decided that looks more like a linear equation. You're not going to need the need of those parameters. And it simply put it out into a more tower-like structure from the image prompt. These are examples of where I would logically have to do that through a node and program editing, but the AI behind it is actually doing that for me. So pretty exciting stuff. Let's go on to here. This is where I'm trying to push the organic nature of things again, using that revolution of the gherkin. So I went in and I simply wanted to make a wine glass. It did some strange things to start, and I will go back and show you that iteratively, but at least I knew it was running that swoped kind of form. And as I stepped through it, asking it to get rid of the top section, I wanted access to those coefficients, which are here, and then I wanted to play with those coefficients all the way through, and I actually thought I'd throw in the term, why don't you apply some nonlinear transformations to it? And that's exactly what it did. So in running those scripts, I thought, well, let's prompt it with a couple of images. It wasn't as close as the tower, but it was making an effort to try and look at these. I pulled in a little bit of a code that would allow me to hollow it and shell it, something that's familiar in a tool like Rhino and Grasshopper. And in the end, I'm able to have a pretty controllable hollow vessel that in glass form, you can see this is actually hollow all the way down to its base, ready for print, ready for modification. And as far as I'm concerned, this is a wonderful little video game for someone to play with who wants to produce vessels. You could go farther. logically and try and get handles on it that are parametric. A perfect example of having a file that's loaded and then you want to go in and make a copy of it because you like the version that you have. Now we're going to get even trickier. This is one that I have an example of. It's basically a polygon that goes a certain length, rotates, pivots, then hits another polygon, rotates, pivots, and it's only a shape that's probably a fifth the length of this because I have a box away, square array going on it. Let's call it a rectangular array. But the reason I wanted to show this is I could take this model and I could go into saving it and save it as my GLB. The magic here is we are working on this development with Grasshopper, that I have a fader node that I've played with, and I think my face is in front of it. But you see as I move it over, I've just put it up in my script tab, my math script tab, so I can drag it down with this icon. But when I refresh, this will update to the changes that I do in fader. So I'm sorry if this video is going a little long, but I obviously wanted to get done a few use cases. Let's just take the rotation to 270 degrees. Let's take the Y rotation to 90 degrees, the Z rotation to the Y degree. Let's make the rows so we can see the change to 8. Let's take the array columns down to 2, and let's change the spacing to 34, and we'll move this spacing back up to 15. I could do anything else. I'll validate it. It will update in fader, but what I want you to see is that geometry transforms itself. Now I can jump back over to Rhino, and I can reread my script, and it will update to what was happening. This is the fourth kind of magic point. If you send somebody a Rhino file, say it has some Grasshopper associated it, they have no understanding of the node scripts and what's actually going on up in the ribbon tool. They can take that file, see it as a fader file, apply it back into fader, and with the existing program, which I have over here collapsed, they can text prompt, image prompt, and certainly, without even getting into that, they can have the parametric control right here. My name's Michael Wickerson. I am the senior researcher at Fader, and I am enjoying my summer more than any summer I've had before, and I wish you all the best. Thank you for watching.